Hi class, it's Bill Berry back, continuing our review of object-oriented programming in our first week of the Java 2 class. We're going to jump down and continue what we were doing. Remember, we started by drawing two UML diagrams to get us started. We did a class diagram and an object diagram. These are your first two deliverables for every project, and so it's a good review. We're going to now code these things up, and I'm going to use, for our particular trial here for a particular project, I'm going to use BlueJ. BlueJ is what I'm going to ask you to turn in your work in. If you want to use some other IDE, that's fine, but I want you to make sure you package it up in BlueJ before it gets to me, because I can't go fix up everybody's code to work from every different kind of IDE in the universe. If you want to do something different, great. Just make sure you package it up and make it work in BlueJ right before you turn it in. It's not that big a deal to do those things. So the first thing I'm going to do in BlueJ is I'm going to create a new project. So I'm going to say new project. I'm going to choose where to put it first. Make sure you put it somewhere you like, and I'm going to call this the bank. So I'm going to save it. Notice that what happens here, let me come out here and just verify to you, show you that what's going to happen here, I guess maybe I don't want to save that. I just want to, there we go. I'm going to show you what is being created here. So if I look, I'm going to see that it's created a folder called bank, and within that there's going to be a package. You can double click that to start BlueJ. That's the sort of project file. And then all your classes are going to be in here, plus all the compiled bytecode files and stuff like that. So everything's going to be in that one folder. So I'm going to start by creating some new classes, and the first one's going to be bank, and that's going to be a class. I'm going to say OK, and then I'm going to say new class, bank account. And I'm going to say OK. One thing that I like about BlueJ is that it is, in essence, this is a skeleton UML class diagram, and it'll actually show the interactions here. So I like that, and we'll find that this is a fine academic tool for doing this programming. You can also edit these templates. Ask me about that offline. You can edit your template so that when you double click one, it comes up with something that you like I've changed mine, so it gives me a description of something that's a little less. It doesn't have a bunch of sample junk in here that I have to get rid of. So I'm going to, for the moment, get rid of this stuff. We're going to come back to JavaDoc soon, and I'll do that for both of mine so that I sort of start with a clean thing. Again, don't really need to do the JavaDoc just at this moment, so we'll just clean that stuff up. All right, great. Now, let's go start coding these things up. Now, I hope that you see that if you start now with the, where's the thing, with the class diagram, I hope you see that if you start here, and by the way, I would start with bank account, right? Start and work on these projects backwards. I'm going to start with bank account because it's a tool, it's a building block on which bank is built. And if I build bank, I can't finish it because I have to have a bank account to do that. So start backwards and sort of work your way from smallest to largest. But I hope you see that all this stuff that's here, in fact, I could go copy all of that stuff perhaps, right? I could just go to the box and copy it. This is a work list for what you need to do. Right, and then there's some other stuff in the handout that talks about things like, you shouldn't have negative, you can't ever have a negative balance, and there might be some other preconditions. But let's just get started. So I'm going to start with bank account, and then maybe again, just as a little note to myself, maybe I actually go and paste in the stuff from the UML and make this all in a big comment block, right? So I have that ready to go. Now, one of the things that you can do, here's the constructor, one of the things that I'd recommend, think about at least, the fact that you can do what's called stubbing. I don't have to write all the code right now. If I get the structure of this set up, there's some advantage to that. So let me show you what I mean. Let me fill in the thing here. The constructor is going to have string, which takes a name, a string, ID, and a double balance, right? I can actually just move on from here, right? I can just move on. I can say public get owner returns a string, doesn't have anything there, and it returns a string, so this is going to be public string get owner. I don't have to actually fill in anything right here. I can actually put something dumb because I don't even want to think about it at the moment, right? I'm just going to return whatever. This is called stubbing. Why is stubbing useful? Because it gives you the full ability to compile. It gets all of the signatures, the names, it gets all of your methods actually there and callable and compiling. Why is that good? Because if you want to do something called test-driven development, after you did this stubbing, you would move to writing your test code, right? You wouldn't write this code yet. You would write your test code first instead. Why is that better? Well, because you haven't written anything here. You're not mentally committed to what you've written. You don't have logic here that you are going to convince yourself must be right because you're a brilliant coder. If you start with stubbing and then go to testing, you will think a lot more deviously about your tests. You'll be a lot better tester. And then you come back and you think about all the stuff that you learned and thought about while you were testing, and then your code will be stronger, right? Your code will be more able. So you can just do this, right? So let me fill in a couple more of these right away. So here we have all of our get methods all fleshed out, but again, just stubbed. And then we can keep going down the list. So I can do public, let's see, public void set owner. I'm writing UML. Don't forget to switch gears to Java. Don't keep writing UML. This doesn't have to have anything in the stub and so forth. Let me keep going. Oh, actually, let's do the next one together. So we do public double, and this one's going to be deposit money, right? Deposit, and we're going to have an amount that's going to be a double. Right, again, you don't have to necessarily do anything here except we're going to return the new balance. So I'm just going to return this for now. And we can do the same thing for withdraw. All right, so I'm just going to change this to withdraw, and we just return nothing. We can also make a toString. So public toString, and that's going to return a string, of course. And you can just throw in something there, but for the moment, again, I don't really care. Now, this has all been stubbed in. I can get rid of all this now because I don't need it anymore. And so I can go start writing my tests and go back to the document and start making sure I've thought about preconditions, thought about challenges, provided any kind of other challenging code, challenging ways to sort of make my code. What will break it? What will stretch it to the limit? Have we forgotten anything? Did the people who wrote the spec forget something that you need to include? So you can absolutely go start testing here. Now, if you want to do that, great. We're not going to talk about the testing till another video, so we won't do that here. But now I think you hopefully can see we can go and start working with our data. But that's a perfectly valid stubbed start to this thing. So now we can certainly go back, and again, we go to our diagram because we've already thought through all this stuff, right? So in the bank account, we've already thought about the attributes. We know what's going here. So I can just paste those and then turn them into Java. String account ID, right? String owner, and etc. Right, so there's my private instance variables. Of course, we always want to mark them. I'm going to copy and paste them because I'm lazy. I don't want to type them again. Now we can start in and start writing our actual code. So in the constructor, of course, the main job of that, not the only job of the constructor, is just to assign variables, right? The job is to make sure that the object has everything it needs to be functional, right? I call it breathing life into the object. So in this case, this dot owner equals name. This dot ID or account ID equals ID. This dot balance equals initial balance. Remember that if any of these matched, right, if this was the same name, that's why sometimes you do like this dot owner equals owner, right? If this had been owner, this could look like this. Oops, if I could type, right? That would make sense here because this is the parameter and this is a qualifier that would guarantee you're talking about the instance variable. So we're not doing that, but we have different ones, but that's perfectly good, right? So you need to do that here. Obviously, if you're going to get owner, you're returning the owner. If you're getting the ID, you're returning the account ID. If you're getting the balance, you're returning the balance, right? These should almost write themselves. In fact, you can imagine a good tool would take that class diagram and actually turn it into a skeleton like this, right? Setting the owner, we want to say this dot owner equals name. But you'll notice we've duplicated code. right, between this and the constructor, even this amount of duplication should set us to thinking that maybe we don't need to do this, right? So this is a good way to do this, right? You can call setOwner name here, where you just pass the name here that was passed in, pass it along and call setOwner from here so you don't duplicate this code. We're going to see when we put preconditions that that might be a really good thing. We've already kept ourselves from duplicating some code. Okay, what else do we need to do here? Well, obviously we need to say what happens when you deposit money. We are going to return something, but first we need to deposit it, right? We need to say balance plus equals amount, and then we want to return the balance. Okay. Interestingly, in Java, you could just say return balance plus equals amount, right? You don't have to actually do this on two lines. You could do it together because even this assignment will have a result that you can count on. So you can certainly do it that way. And this is going to look very familiar, except that we're going to take away from the balance. And the toString, I mean, for the moment, we can just sort of be a little bit lazy and we could say, you know, return ID plus maybe \n plus owner. It's actually account ID, isn't it? ACCT ID plus owner plus \n plus balance. Right? So we can sort of put in something there real quick and maybe we can make it prettier later. Right? But everything here now is coded up, ready to go. The only thing we need is to think about preconditions. Go back to our document and see if it has anything to say about that. Bank accounts, identification, balances must never be below 0. Right? So there's one thing that we probably should do, and that's that we should make sure that this initial balance is not ever less than 0. We should also document that, which we'll figure out how to do soon. So one of the things we'll do is write a precondition, right? If initial balance is less than 0, then throw new typical illegal argument exception, and always put a note, initial balance can't be, or must be positive, can't be less than 0. Right? Can't be negative. You could say that, right? Can't be negative. All right, so always make sure that you throw a good thing. Also, do these precondition checks first, because there's no point in doing any of this work if you're just going to bail out, and this is going to bail out, right? The throw is going to get you out of here and bail out. So always do that first, and then do whatever you need to do next. And then we also want to think about if there's any other things, like it's typical for us to want to be careful about names, right? If you're going to provide a name, it probably shouldn't be null and it probably shouldn't be empty, right? So in this case, owner name is going to be done down here. So why don't we do a check down here, right? If name is equals null, or name dot is empty, right? If it's an empty string, then we probably again want to say name cannot be null or empty. Empty. All right, so something like that. That way, and again, you're calling the set from the constructor, so it's already taken care of there. Right? So that's really good. We could also do the same for ID, right? We probably shouldn't have an ID. So if ID equals null or is empty, in fact, either one, right? Is null or ID. Same thing, right? Throw new. Of course, cut and paste, right? You don't have to do all this stuff. ID must not be empty or null. All right, so do your precondition checks. See if there's anywhere else where we need to do that. Well, deposits, we said in this spec, let's go back there real quickly. All right, blah, blah, blah. When account is open, blah, blah, blah. Provide ways to be money to deposited, withdrawal, and deposit amounts must always be non-negative. So we want to do a negative check on that. Now, if you find yourself doing a bunch of these, of course, bring them out to a helper function, right? Again, we're duplicating code. So make a helper function, pass in the thing that you're checking, and pass in a little string to represent what it is, and then you can always throw the exception in a helper function. We never want to duplicate code, right? That should be kind of a clear thing. So we want to check this here. If amount is less than 0, throw and we'll say amount must not be negative. All right, and then we're going to do the same thing here, which again, we're cutting and pasting. That's a pretty good sign that maybe we should think about putting that into a helper function, right? Now, the other thing here is balances can never be negative, so this isn't the only problem, right? If the amount is less than 0, or if we have this other problem, right? If amount is greater than the balance, that's another problem, right? Because balances can never be below 0. Right? That's something that should always be true here, right? It's stated in the document. Then we have another one, right? The legal argument exception that says amount must not be greater than balance. Okay? So you can certainly go through and flesh all of these things out. Remember that you're going to need to test them, right? We're going to need to make sure that all these are coded correctly because it's very easy to make mistakes with our operators. It's very easy to make mistakes and use and instead of or instead of and, get these symbols wrong, right? All of those little things are going to be stuff that you're going to find with testing. Okay, so hopefully that makes sense to you that all of this stuff is going to be coded this way. We're not doing any interaction between objects yet. This is just plain old object-oriented code review. So hopefully everything makes sense here. I'm going to pause for a second. If you want to review this code, stop and look at it here or take a screenshot, and I'm going to page down. Okay, here's the next set of things. Set owner, deposit, and withdraw. And last but not least, the toString. So all of this needs documenting, all of it needs testing, but that's not our concern just at the moment. We're going to stop here. We'll come back and take care of the actual bank object class in just a second. But the video is getting long, so let's stop here. Thanks for watching this one. Let me know if you have any questions.